bar x as a symbol denoting arithmetic mean. Now, bar x means what? Arithmetic mean. And now, when you are given a set of data, to find mean, the arithmetic mean, you say the summation of the data given, x, over the number of the data, that is when you count the number of the data. For instance, let's say 1, 2, 3, 4, 5, and 6 are set of data. Now, the mean of these data is the addition or summation of all these members. So we say arithmetic mean equals to summation x over n, which is equals to 1 plus 2 plus 3 plus 4 plus 5 plus 6, all over the number of data 1, 2, 3, 4, 5, 6, which is 6, which is equals to, when you add this is 1 plus 2, 3 plus 3, that's 6, plus 4, that's 10, plus 5, that's 15, plus 6, that's 21. That's 21 over 6, which is equals to, so 21 divided by 6, which is equals to 3.5. That is 3.5 is the center of this data. Like all this data now, the middle part of this data is this 3.5, which that is the function of arithmetic mean. You being able to get the center, the middle part of a set of data. Now let's look into more example. Now in this example, the question says the table below shows the frequency distribution of marks scored by 30 candidates in an aptitude test. Now this is the mark and the frequency. Now in this example, which is different from the earlier example, now this example has frequency. And what is the frequency? Frequency is telling us the number of times the mark is being accorded, or the number of times that people got the mark. That is, people that score 4, they are 5 in number. That is, this mark occur 5 times. So to solve this now, what we are going to do is to write our mean, that is average mean, equals to, now at this point now, the formula is not just going to be summation of x over n. It's going to be summation of fx, that is this frequency multiplied by the mark, to tell us, so that it can give us the exact number of mark. So over now the addition of all the frequency, and which is already given from the question that 30 candidates, that means the number of people that got the mark, they are 30, which is summation f. So now this is the formula we are going to use now. So to do this now, what we are now going to do is we are going to use the frequency to multiply its mark. So 5 times 4 plus 8 times 5, 8 times 5 plus 6 times, 5 times 6, 5 times 6 plus 6 times 7, 6 times 7 plus 4 times 8 plus 2 times 9 over 30, which is equals to 5 times 4 equals to, now I want to maximize this space here, that's 20 plus 8 times 5, 40 plus 30 plus 42 plus 32 plus 18 over 30, which is equals to, now when we add this together, that's 60 plus that's 90, that's 132, that's 164, then 182 over 30, which is equals to, so 182 divided by 30 equals to 6.066. The answer is 6.067. By the time you round it up to the nearest whole number, this is the whole number side, we have 6. That is, you rounded 7 to 1, you add it to 6, it becomes 7. You rounded 6 to 1, to 1, you add it to 0, it becomes 1. 1 cannot be rounded up, so it becomes 0. So we have 6. So this is our final answer. Let's look at this second example. All right, now the mean, example 2 now, is actually a question in Waec in year 1991. Now, the mean of 30 observation recorded in an experiment is 5. This is the mean. I guess it's solved already. Now, if the observed largest value of 34 is deleted, now out of all the records, now the highest value there is 34 and is deleted. I get now. Find the mean of the remaining distribution. What is the mean of the remaining distribution? Solution now. Solution. We have mean, average mean equals to summation of frequency times data over summation of frequency, which is equals to, now we're told that the mean of 30 observation is what? Now what are the parameters given? The mean, which is equals to 5, then the frequency, they say is 30. Now that's the number of the observation. Now this value is what we don't know. We can use these two values to get this value. When we have this and this, we can get this by means of subject of formula. So now we have summation fx over summation f equals to, now 5. Now let me put what this, I've said this is 30. Are you following me? So now cross multiply, summation fx equals to 30 times 5, which is equals to summation 150. That means the addition of all the observed, the experiment recorded is 150. Now this is the observation recorded in the experiment. This is the summation of it. This is the addition of everything. So now the question now says that the highest value is 34. The highest value inside this 150 is 34. So, and it's been deleted. So when out of 30 observation, 1 is deleted, that means we have 29 observation. Now when it was 30 observation, the summation of the frequency and the data is 150. Now we're told that out of the 150, the largest value, which is 34, is deleted. So we'll subtract this 34 from 150, which we will have 116. So now having 116, now that means when 1 out of the 30 observation is deleted, the mean is going to be 116. So now the observation will also be reduced by 1. So which is what? Which is 30 minus 1, which is 29. So now the frequency is 29. the summation of the frequency and the data is 116. So with this now, we can now find the mean of the remaining distribution. This is the remaining distribution. So we can now say summation. So now summation fx over summation f equals to 116 over 29, which is equals to 4. Final answer. Thank you.